Okay, so what I want to cover in this short video is the property of linearity in Laplace transforms. We know that Laplace is a linear transform, so I just want to go through the repercussions, what that means, what that practically means, and how we can explore the property of linearity in Laplace. But before we do that, what I want to do is just go over the Laplace transforms that we've done already, just so that we have them and we know what they are, because this is going to really form the basis of everything else that's going to follow. So we know that the Laplace transform of A, remember, if assuming that f of t equals A, the Laplace transform of A is just going to be A on S, and then we've got a few other ones. So the Laplace transform of e to the at is going to be 1 on S minus A. The Laplace transform of e to the minus at equals 1 on S plus A. We've got the Laplace transform of sine at, the trigonometric ones now. Remember, that's going to be A on S squared plus A squared. And then we'll have the cosine as well. So the Laplace transform of cosine at is going to be S on S squared plus A squared. And then we've got the hyperbolic trigonometric transform. So we'll do sine at. And that's going to be A on S squared minus A squared, and the Laplace transform of cosh at. And that's just going to be S on S squared minus A squared. And then we've also got the transform of t to the n. We said before it's going to be n factorial on S to the n plus 1. So those are the main ones. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 transforms here, which is a good starting point. Now that we've got that, we can actually do some Laplace transforms. So let's have a go. And what we'll do is we'll explore this property of linearity as well. So if we have, say, let's say AF of t plus B G of t, and we want to know what the Laplace transform of that is. Okay, but if Laplace is a linear transform, what it means is that we can do the following. We can say that that is equal or identical to the Laplace transform of A f of t plus the Laplace transform of B G of t. And we can say that that's going to be the same as A times the Laplace transform of f of t plus B times the Laplace transform of G of t. This is absolutely essential in all the work that we do with Laplace. The property of linearity. So if we have, let's take an example now of let's say the question was the Laplace transform of 2e to the minus t plus t. Okay, well, property of linearity states that that's equal to the Laplace transform of 2e to the minus t plus the Laplace transform of t. Yeah. Equals 2 times the Laplace transform of e to the minus t plus the Laplace transform of t. So we know that the Laplace transform of e to the minus t equals 1 over s plus 1. And we also know that the Laplace transform of t to the power of 1 is going to be, remember from our work that we did on t to the n, we do Laplace of t to the n equals n factorial to the n plus 1. Whoops. Well, that's going to be 1 factorial on s squared. So we can bring that down, and we can say that the answer is going to be 2 times 1 on s plus 1 plus 1 on s squared. Yeah? Which equals 2 on s plus 1 plus 1 on s squared. And we can simplify that, obviously, by saying 2 s squared plus s plus 1 on s plus 1 s squared. So now that comes to 2 s squared plus s plus 1 on s squared s plus 1. And that's the answer. That's the correct answer. Yeah, 2s squared plus s plus 1 on s squared plus s plus 1. Okay, let's do another one. let's do the Laplace transform of 2 sine 3t plus cos 3t. So we know from the principle of linearity that's going to be equal to 2 times the Laplace transform of sine 3t plus the Laplace transform of cos 3t. Yeah? And that's going to be equal to 2 times 3 on s squared plus 3 squared, which is 9, plus s on s squared plus 3 squared, which is 9. Okay, so that's going to be equal to 6 on s squared plus 9 plus s on s squared plus 9. We can easily see that this is going to be s plus 6 on s squared plus 9. And there we go. Let's do another one. So let's do, say, the Laplace transform of 4e to the 2t plus 3 cosh 4t. So that's going to be, from linearity, that's going to be equal to 4 times the Laplace transform of e to the 2t plus 3 times the Laplace transform of cosh 4t. Yeah? So we can say this is going to be equal to 4 times 1 over s minus 2 plus 3 times s on s squared minus a squared. In this case, it's going to be 4 squared, it's going to be 16. So we're left with 4 on s minus 2 plus 3s on s squared minus 16. Okay, so let's simplify this even more. So we can say that that's going to be 4 s squared minus 16 plus 3s s minus 2 on s minus 2 s squared minus 16. Let's check that that's correct. Yeah, that's going to give that. And s2, 3s, yes, I believe that looks good. So let's expand that. So it's going to be 4 s squared minus 4 times 16, which I should be able to do in my head, but I can't. So 64 plus 3s squared minus 6, all on s minus 2, s squared minus 16, okay, so 4s squared plus 3s squared, that gives us 7 s squared, minus 64 minus 6, 1 second, I've done something wrong here, 3s squared minus 6s, so actually minus 6s minus 64, all on s squared minus 16, s minus 2. There we go. Oh, sorry, couldn't see that, could you? There you go. And that's the final answer. Okay, let's do another example. So the Laplace transform of 2 sine 3t plus 4 sine 3t. Okay, so stage 1, property of linearity, 2 times the Laplace transform of sine 3t plus 4 times the Laplace transform of sine 3t. So this is going to be equal to 2 times a on s squared plus 3 squared plus 4 times the, 4 times the final sine, that's going to be, sorry, I'm going to put a in there, it's going to be 3, that's going to be 3 on s squared minus 9, isn't it? So that gives us 6 on s squared plus 9 plus 12 on s squared minus 9. And then what we would do is just simplify that. I'm not going to do the whole thing here, but then that will actually go to 18 s squared plus 54 on s to the 4 minus 81, which then goes to 18 s squared plus 3 on s to the 4 minus 81.